Look up at the night sky. On a clear, moonless night, you are looking at roughly 3,000 individual points of light. To the naked eye, they seem eternal, static, and peaceful. But the reality is far more violent and terrifying. Every single photon hitting your retina has traveled across a graveyard of dead stars, through voids so vast they defy human logic, to reach you at this precise, fleeting moment. Image, a wide-angle, breathtaking shot of the Milky Way galaxy arching over a dark, jagged mountain range. If you were to take a grain of sand and hold it at arm's length against the darkness of the sky, the tiny patch of space it covers contains thousands of galaxies. Each of those galaxies holds billions of stars, and around those stars, trillions of planets. We are living in a cosmic house of cards, built on a foundation of physics that, by all rights, should have caused the universe to collapse in its first microsecond. Image, a close-up of a human hand holding a single grain of sand against the backdrop of a starry night sky. Today, we are going to peel back the curtain on the cosmic engine. We aren't just talking about planets or moons. We are diving into the architecture of reality itself, the dark forces that pull galaxies apart, and the terrifying possibility that our entire universe is a momentary glitch in an infinite, cold nothingness. Image, an artistic, high-definition digital rendering of the Big Bang, showing an explosion of light and matter from a singularity. The story of the universe begins with a contradiction. We have a set of physical laws, gravity, electromagnetism, and the nuclear forces, that govern everything from the orbit of the Earth to the decay of an atom. Yet, when we apply these laws to the universe as a whole, the math screams that something is fundamentally broken. Image, abstract animation of mathematical equations floating in space, slowly dissolving into stardust. If you want to understand why you are here, you have to understand the size of the room you're standing in. The observable universe is 93 billion light-years across. That is not a distance, it is a limit of information. Beyond that bubble, the universe is expanding away from us faster than the speed of light. Image, a zoom-out effect starting from Earth, moving past the solar system, the galaxy, and finally into the vast cosmic web. This means there are parts of the universe that we will literally never see, never touch, and never interact with. They are gone, pushed over the cosmic horizon by the expansion of space itself. And that expansion isn't slowing down, it's accelerating. Image, a CGI animation of galaxies drifting apart from one another, with the space between them stretching and glowing. Why? Because of something we call dark energy. We don't know what it is. We can't see it, touch it, or measure it directly. But we know it accounts for roughly 68% of everything that exists. Imagine you have a bank account, and 68% of your money is just gone. You can't see it, but you know it's there because it's draining your account every single day. Image, a conceptual representation of dark energy as a semi-transparent, swirling violet mist filling the void between galaxies. That is our universe. We are living in a home where we only understand 5% of the furniture. The rest is dark energy and dark matter, ghosts in the machine of the cosmos. Image, a dark, mysterious silhouette of a person standing in front of a giant, glowing telescope monitor. Let's talk about stars. Our sun is a middle-aged yellow dwarf, a steady, reliable engine that has kept Earth warm for 4.5 billion years. But in the grand scheme, it's a tiny flicker. Image, a high-resolution stock video of the sun's surface, showing solar flares and bubbling plasma. When stars like ours die, they shed their outer layers, leaving behind a white dwarf, a dense, cooling core the size of Earth. But when massive stars die, they go out with a scream. A supernova is the most violent event in the known universe, briefly outshining an entire galaxy. Image, an animation of a massive blue star collapsing inward and then exploding in a brilliant supernova. These explosions are the factories of existence. Gold, silver, iron, calcium in your bones, all of it was forged in the hearts of dying stars. You are literally made of stardust. Image, a macro shot of a human eye, transitioning into a vibrant nebula with swirling gold and metallic hues. But even these titans have a lifespan. Eventually, stars will stop forming. We are currently living in the stelliferous era, the golden age of the universe. In a few trillion years, the last stars will flicker out. The universe will become a cold, dark graveyard of black holes and dead planets. Image, a long shot of a lone, dim star fading into total darkness against a black background. Think about the silence of that future. No light. No heat. No life. Just the slow evaporation of black holes via Hawking radiation. Image, an artistic representation of a black hole, with light bending around its event horizon. Is it depressing? Maybe. But it also makes this moment, the one you are experiencing right now, infinitely precious. Image, a soft, cinematic shot of a person looking up at the sky from a balcony at night. Let's look deeper at the architecture. Gravity is the architect of the cosmos. It draws gas into clouds, clouds into stars, stars into galaxies, and galaxies into clusters. But gravity is weak. A tiny magnet can pick up a paperclip against the pull of the entire Earth. Image, a scientific animation showing the gravitational lensing effect, where light bends around a massive object. Yet, across the distances of space, gravity is the king. It creates the cosmic web, a vast, interconnected structure of filaments that span billions of light-years. Image, a 3D map rendering of the cosmic web, showing glowing filaments connecting galaxy clusters. These filaments are the superhighways of the universe. Galaxies move along them, feeding on the intergalactic gas they provide. Image, a time-lapse style view of galaxies slowly moving along invisible lines of force. But even these highways are breaking. The acceleration of the universe is stretching these filaments thinner and thinner. Image, a close-up of a cosmic filament being stretched and frayed, like a piece of silk. This brings us to the question of probability. There is a concept called the anthropic principle. It suggests that the universe has the properties it does because if it didn't, we wouldn't be here to observe it. Image, a montage of human life, a heartbeat monitor, a newborn baby, and a busy city street. If the force of gravity were just a fraction of a percentage stronger, the universe would have collapsed back into a black hole nanoseconds after the Big Bang. If it were a fraction weaker, stars would never have coalesced. Image, a visual comparison of two different universes, one crushed and one empty. We are living in the Goldilocks zone of existence. The constants of physics are tuned to a degree of precision that feels almost intentional. Image, a macro shot of a clockwork mechanism turning, representing the fine-tuning of physics. Some scientists argue this is proof of a multiverse. Maybe there are infinite universes, each with different laws, and we just happen to win the cosmic lottery. Image, a conceptual art piece showing 1,000 floating mirrors, each reflecting a different version of a galaxy. Others argue that our universe is a simulation, a digital playground where the variables were set perfectly to observe the emergence of complex life. Image, a digital, glitch-like effect washing over a view of the Earth from space. Whatever the case, the mystery is deep. We are constantly finding things that challenge our understanding. For instance, the James Webb Space Telescope recently captured galaxies that were far too mature to exist so shortly after the Big Bang. Image, a high-definition, color-corrected image from the James Webb Telescope, showing early, bright galaxies. They shouldn't be there. Our models say they need billions of years to form, but there they are, appearing in the dawn of time, fully grown and hungry. Image, a zooming shot into the deep, dark corners of a galaxy cluster. It's a reminder that every time we think we have the universe figured out, it changes the rules on us. Image, a scientist working in a high-tech lab, pointing at a monitor full of data points. Think about black holes. They are the ultimate cosmic paradox. They are regions where space and time are so warped that they fold in on themselves. Image, a dark, swirling vortex in the center of a galaxy, represented as a gravity well. If you were to fall into a black hole, your watch would slow down relative to the outside world. To you, you'd cross the horizon in seconds. To an observer outside, you would freeze at the edge, slowly fading as the light from your body redshifts into invisibility. Image, an animation of an astronaut drifting toward a black hole, slowing down as they reach the event horizon. You would be caught in a frozen moment for eternity. Is that what the universe is? A collection of frozen, unfolding events. Image, a fast-paced montage of stars exploding, planets orbiting, and nebulas glowing. We've sent probes to the edges of our solar system. Voyager 1 is currently in interstellar space, carrying a record of humanity into the great unknown. Image, a model of the Voyager space probe drifting through the emptiness of space. It is the farthest man-made object, a tiny needle in a haystack of absolute vacuum. And yet, it is still within the front yard of our solar system. Image, a scale representation of the solar system, with a tiny dot showing Voyager's location. When you consider that the nearest star is 4 light-years away, you realize how isolated we really are. Image, a lone, flickering star in the distance, surrounded by endless black. The loneliness of the universe is a common theme in astronomy, but perhaps it's a misunderstanding. Maybe the universe isn't empty. Maybe it's just waiting. Image, a radio telescope array sitting in a desert, pointing toward the deep sky. We are looking for radio signals from other civilizations, but what if they are using technology we haven't even dreamed of yet? What if they are communicating through gravity waves, or entangled particles that transcend space? Image, a visual representation of invisible, rippling waves moving through the fabric of space. The universe is expanding. The gap between us and our neighbors is growing. We are effectively becoming more isolated by the second. Image, a long, slow zoom out from the Earth, showing it getting smaller and smaller until it vanishes. This brings us to the climax of our journey. Why does any of this matter? Why are we, these fragile, carbon-based creatures, so obsessed with looking up? Image, a montage of human eyes looking at the sky, a child, an elderly person, an astronaut. The revelation is this: we are the universe's way of experiencing itself. That isn't just a poetic quote, it's a biological fact. Image, a close-up of a human neural network, transitioning into the structure of the cosmic web. The atoms in your body were fused in the belly of a sun. The neurons in your brain are arranged in a pattern that reflects the growth of the universe. Image, an animation showing the striking similarity between a human brain and a galaxy cluster. You are not just an observer of the universe. You are a participant. You are a conscious manifestation of the Big Bang, still expanding, still learning, still wondering. Image, a beautiful, artistic shot of a person looking up at a meteor shower. The universe isn't a cold, dead place that created us by accident. It is a system that has spent 13.8 billion years evolving to the point where it could finally grow eyes and look back at itself. Image, a cinematic shot of the Earth from the moon, showing the blue marble against the infinite black. We are the universe's mirror. Every time you ask a question about space, the universe is asking a question about you. Image, a montage of humans looking through telescopes, typing on computers, and dreaming. So, as we reach the end of our dive into the deep dark, remember that you are here, at this specific place, at this specific time, for a reason. You are the light in the dark. Image, a final, powerful shot of a sun rising over the curvature of the Earth. We are going to continue to explore these mysteries in our upcoming videos, from the secrets of quantum entanglement to the search for life on moons like Europa. If you found this journey as mind-bending as we did, please hit the subscribe button and turn on notifications. Image, a subscribe button animation appearing on a starry background. There is so much more to discover, and we want you with us for the ride. Leave a comment below. If you could travel to any point in the universe, knowing you could never return, where would you go? Image, an interactive graphic asking the question, where would you go in the universe? Until next time, keep looking up. The universe is waiting to be understood, and it's always listening. Image, a final wide shot of the night sky, transitioning to a simple, clean, dark screen with the channel logo.